Suppose a circuit breaker connected to a generator on no load and at rated terminal voltage. The circuit breaker is in open position and other side of circuit breaker is short circuited. Let the circuit breaker be closed at the instant when the voltage of terminal B with respect to neutral is 0. In such a case, the short circuit current in phase B will have maximum DC component and the waveform of current IB will be unsymmetrical about normal zero axis. Let's understand this concept by using the waveform of current IB. The generator is on no load before T is equal to T0 and therefore current is 0 before T0 instant. At T is equal to T0, short circuit is applied and current increased to high value during the first quarter cycle. The peak of the first major current loop is instantaneous value of current. And this instantaneous peak value of major current loop is called as making current. This current is called as making current because ideally at this instant the contacts of circuit breaker should open, but the contact is in closed position and closed means make. The circuit breaker contacts separates after few cycles. Since relay and operating mechanism takes at least a couple of cycles. To understand why it will take few cycles to open the contacts, watch my video how circuit breaker and relay works. Video link is available in the description box. Let's assume the circuit breaker contacts separate at T is equal to T1. The RMS value of short circuit current at the instant of contact separation is called as breaking current. This current is called as breaking current because at this instant contact opens and open means break. After the separation of the contacts, an arc is drawn between the contacts. The arc current varies sinusoidally for a few cycles. At T is equal to T2, at a particular current 0, the dielectric strength of the arc space builds up sufficiently so as to prevent continuation of the arc. At the current 0, this arc is extinguished and is interrupted. Now, let's discuss the voltage between the contacts. At T is equal to T0, the contacts are closed and the voltage between them is 0. After the separation of the contacts at T1 instant, the voltage across contacts increases. In fact, this voltage is the voltage drop across the arc during arcing period. Therefore, it is called as arc voltage. At T2 instant, when arc gets extinguished, a high frequency transient voltage appears across the contacts which is superimposed on power frequency system voltage. The high frequency transient voltage tries to restrike the arc. Hence, it is called as restriking voltage or transient recovery voltage. If the dielectric strength of the medium between the contacts does not build up faster than the rate of rise of restriking voltage, then the arc will restrike again. But if the dielectric strength of the contact space builds up very rapidly so that it is more than the rate of rise of restriking voltage, the circuit breaker interrupts the arc successfully. Let's understand this concept by using a simple example. Suppose a small dense of fire is established. A small amount of air is sufficient to vanish the fire. Here, fire is in the role of restriking voltage and air is the dielectric strength of the medium. Dielectric strength of medium is more than the restriking voltage. So, arc will not restrike. But if the density of fire is more and it increasing rapidly, then air is not sufficient to vanish the fire. It restrike again. Instead of air, we need a medium of higher dielectric strength to vanish the fire, like a fire extinguisher. Finally, when the arc extinguishes, the power frequency system voltage appearing between the contact is called as recovery voltage. This is about the current interruption in AC circuit breaker. Thank you.